Welcome back, guys. So today we'll jump into how to converting an alternator into a three-phase motor and using it to power a what used to be gasoline moped scooter. Alright, so we basically start off by just stripping it apart, taking off the plastic covers as well as the brush pack. So the way we're gonna be converting this is basically stripping out the brushes as well as the regulator pack. So the brushes are still gonna be used. So the brushes apply 12 volt to the armature, turning the motor into a permanent magnet motor basically. So you apply 12 volt to the field, then it creates resistance, and as soon as power is applied to the three-phase motor, it acts as a permanent magnet three-phase motor. Alright, so we're also going to be removing the diode pack, as you can see. So this one is just crimped on. You just open up the tabs and remove the diode pack. So we just want the alternator with the wires exposed basically. So we're not going to be using the diode pack, as we're not going to be using it as an alternator. So yeah, as you can see, there's the bare alternator. Now we're just going to be cleaning up the wires a little bit. Alright, and then once we finish to clean the wires, we're going to be testing to see there's supposed to be 3 different coils inside the motor. So here we'll be testing which ones. As you can see, when you touch these ones, it's got continuity. When you touch those ones again, it's got continuity, and those ones as well. So which means that is our 3 different coils: coil 1, coil 2, and coil 3. So in this case, you get 2 different configurations, delta and star. But we're going to be use delta configuration, as it's stronger and equal voltage and amps applied to both all 3 of the coils. Sorry. Instead, in the star configuration, the voltage is divided. So this is star, where the voltage is divided, and this is delta. So you can do a bit more research on the delta and star, but I'll basically show you guys how to connect this in a delta configuration. If you are a bit familiar with the three-phase motors, then you should also be familiar with how three-phase motors work. So this is basically a three-phase motor that's used as an alternator. Alright, so now I'm just going to be soldering on some wires onto the ends of the copper tabs of the coils, and I'll also be soldering them. So just one little bit of recommendation is to use a proper soldering iron along with some bit of flux. They can be a little bit tricky to solder sometimes, and you need to ensure that you do solder them properly, as a lot of power and heat is going to be going through the wires. So yeah, almost done soldering them. Alright, so now we'll be adding a little bit of heat shrink onto them, making sure they're properly sealed so there's no short. As I said, there is a lot of current running through these wires. And now soon we'll get to the important and the fun part of turning the alternator into a brushless DC motor. So on the 3 coils we have, so basically what we're going to be doing, we're going to be using one end of coil 1 and connecting to the one end of coil number 2. So yeah, and then same with 2 and 3. So we'll connect those ones together. Alright, then we move on to the one for coil 2 connected to the tab of coil 3 for the one winding, and then the one from number 3 back to number 1. And then these 3 points that's sticking out, it's basically your delta connection. So I'll be soldering 3 wires onto them, and then also applying a bit of heat shrink onto them. And that's basically how you convert it into a 3-phase delta wired motor. And like I said, we're still going to be using the brushes, so we're going to be connecting the brushes back onto it. And then onto the brushes, we'll obviously either solder the wires onto it, or we'll get a plug to be able to supply the brushes with a constant 12 volt voltage, allowing the alternator to operate as a 12 volt brushless permanent magnet motor. Alright, so yeah, now we're just putting everything together. So here in the next clip you guys will see, this was the first test. The first one is just for demonstration purposes to show you guys how it's done. But this is the one that I did use in the electric scooter. So as you can see, there is the first test where I connected it directly up to only 24 volts at that time, just to see if it is running. I did not connect an accelerator onto it. So you basically can buy these brushless DC controllers for the e-bikes on Wish, Genu, online. There's a lot of places, Amazon, yeah, all these places you can get them online. You just have to do research. So I opted to go for a 72 volt one. And then this was the first test run with the alternator installed onto the scooter. So basically you can see I do have a throttle onto it, got a few batteries hooked up there, and it is running good. I basically utilized the gearbox of the scooter to get the torque that's required, but I didn't use the front part of the motor where the piston and the crank and all those things are. So it doesn't look that fast, but it is quite nippy. And yeah, there's the first test run. It was still a bit disassembled, but just to ensure that it does indeed have the power and the torque required to continue with the project. Alright, so as you guys can see, it is going well. I did a bit more assembly, still in the beginning phases, so just tied a box with a few batteries onto it, and this was basically the speed test to see what the top speed is gonna be on it. As I said, it does go quite fast, so yeah, it's, compared to normal electric scooters, I think it is much better. This was also run on 72 volts and about 35 to 40 amps. I've also asked my father-in-law to give me a hand and also take it for a bit of a test drive to see if it can handle a bit of weight and still have the torque to be able to drive properly. Hi guys, just thought I'd give you an update. This is the scooter that I've built. It's a Yamaha Maya Mio or something like that. So basically I've used an alternator connected directly to the gearbox of the scooter, not utilizing the front part of the motor or the clutches, which is just not necessary. Then it's got a twist throttle right there. The voltage is a bit low, I don't know if you can see, but it's currently 77 volts. And then I've also connected the ignition switch, so this runs all the other stuff like lights and stuff like that, and indicators and all the stuff like that. Okay, so switch that off. So yeah, basically I've used an alternator. I think it's like a 45 amp or something like that alternator. Then down there I've got a brushless controller, just a cheap Chinese brushless controller, which is rated, you can run on 48, 60 and 72 volts from 25 to 35 amperes. Then here I've also got a Chinese converter which steps down the voltage from 36 to 72 volts down to 12 volts. So you connect your 72 volts or your 32 volts or whichever voltage you have, and it converts it down to 12 volt, 10 amps. And it goes into the scooter,
and then comes back to the brushes of the alternator. So yeah, so currently it is running on 72 volts. I don't know if I said that, but yeah, so it doesn't have all the batteries currently. It's got 12 batteries, 7 ampere batteries, 6 of them connected in series, and in parallel, times 2. Yeah, sorry, 6 connected in series, and then times 2 in parallel, which gives you 72 volts and 14 amp hours. Okay, so basically that's it. Switch on the ignition, and then we push the throttle. So currently I have not done a range test on it yet. Yeah, but I have tested the top speed that I could get on flat roads. It's about, on this clocks, it's about 60 to 70 kilometers an hour on flat roads, about 45 to 50 on uphills, and yeah, downhills you can get about almost 80. Well, close to 80, so I don't know how accurate these clocks are, but yeah, that's basically what I'm getting out of it. So that's it for the scooter. Yeah, and the box that I made. So basically I just had to lift the seat a little bit, make a box to fit all the batteries, because these Yamaha Mios are quite small. It doesn't have any seat storage compartments. Well, it's not very big, so I had to make a plan to be able to fit the batteries. So this battery case will be able to fit 3 times 6 7 amp hour batteries, which will bring it to 21 amp hour at 72 volts. So as I fit the batteries and all these other things and also do a range test, then I'll keep you guys in the loop. So that's it from me for now. Enjoy. I hope you liked it.